Hey, so today I'm going to show you my gravity and pressure network analysis and profiling and optimization tools directly in Autodesk Infraworks. So what you see here on the screen is a typical Infraworks model. I generated this using the model builder. It's actually not far from where I live, so I thought it would be a handy test case. I then proceeded to just create some catchment areas. So to do that is quite simple. If you go to the Analyze ribbon, you've got this watershed button, and all you need to do really is click on it, select a point of interest, and it will automatically from the surface calculate the catchment area or the watershed area. Now, that's pretty cool. I then proceeded to create a pipe network. So there's two different ways of doing that in Infraworks. So you can use normal pipeline and connector elements, or when you use the data shortcuts to import land XML or straight from Civil 3D or shapefiles or whatever, and you use pipe networks, it's going to create a normal pipe network object. But when you import a Civil 3D drainage network element, it's going to use the drainage network components, and they vary slightly from each other. Let me explain. So what we have here is a very small line or system network with a couple of pipes, a couple of branches merging into a main branch. But if you select the elements, you'll see it's a drainage network part. This one is an inlet, it's a manhole. But you can see it's got a bit more of hydraulic information. It's got the catchment, tributary area, and time of concentration and runoff coefficient and stuff assigned to it. So that's information that comes from the catchment. Again, if I select the catchment, you'll see it's got its own properties that's automatically calculated. So that's pretty good. Now, on the other hand, if you just go ahead and model normal pipe elements, so not a pipe network, not a drainage network, just normal pipes, then you end up with these little guys. So when you select them, you'll see they look similar, they behave similar, but they've got different properties. There's no hydraulic or design properties assigned to these pipes. The only thing they've really got is a size, which I've left blank here. And then obviously the pipe start and end node elevations or invert levels. So I created this drainage network, and if I select any of these elements, you'll notice they belong to a network. And then, so there's my drainage network. And then what I've done is in a separate space in my model, I just as a dummy model, I created some pressure network part elements, and I placed these on a network that I just called, oops, looks like my network name disappeared, that I just called WTR01. All right, I actually want to apply that to this line here as well. So let me do it now. All right, so that just means that I've got this little network here. You can see there's multiple vertices. It leads all the way up here where my tank's going to be. And we're just assuming that it's going to supply these houses here. So wherever we've got nodes within my pressure network is where I'm going to have nodes in my EPANET model downstream. For the drainage network, again, where we've got manholes, obviously that's where the manholes are going to be. All right. Now, the way this works is you load a script that I've set up, you run it, it displays this interface where we can see we've got the analysis is currently set to EPA SWMM. We can change that to EPANET, in which case it's going to allow me to select my EPANET model. Needs a little bit of fine tuning. I see I've missed something there. Anyway, we'll get back to it. So now we're in a pressure network sort of environment. And if we go to the EPA SWMM, we're in a gravity network environment. Now, the way it works is you select the downstream node and plan. So let's select that one. It's going to automatically select the longest line, and it's going to create profile view from that. I can, of course, change that. So I can go back here and say, actually, I wanted this line, or sorry, I actually broke it now. Let's just leave it like that. So what we do here now is we say, all right, let's update the profile, and we go back and we can see now we've got our original network, we've got crossing pipes, and we've got the profile with our existing ground surface there and crossing pipes in the profile view. Because if we go back here to Infraworks, I can't show you now because this is open, But I can. There's a crossing pipe there. And I did that on purpose to see if we can display crossing pipes from other networks within this network, because that's what we want to see. All right, now it's automatically brought across all of that rainfall data. So we can see the rainfall, the time of concentration, the tributary areas, etc. that feeds into that. That's all there. So whenever we select on any of these elements, we'll be able to see properties and we can change them. But for all practical purposes, we're ready to run an analysis. So I can run EPA SWMM. That goes through, and you can see now we've got some hydraulic results here in this model, and it's also tabulated here for us. So we can see we've got the hydraulic grade line upstream and downstream, and the energy grade line upstream, downstream. We've got some information on our model here. Now in the future, I want to be able to actually make changes to my model in real time. We can run it now as it is, but we can't bring it back into Infraworks yet. That's the next step. But that's what it does with the drainage network analysis. If we switch to EPANET again and we select the network that we want, all we have to do here is we need to specify at least one tank or reservoir. So I'm going to specify that as my reservoir. And then the rest of these nodes is going to be my demand nodes. So I'm just going to create a big old box around these. Oopsie, I kind of messed it up. That's all right. And I'll just hold Shift to select a few more. Let me try that again. There we go. So I'll select these ones, and I'm going to say these are my demand nodes, and let's say we demand there 10 liters per second, for example. So now that we've got that done, it means that we can run the EPANET analysis. So I'll just click on run. It'll go through. It's going to color code my model, and we can see that we've got results now coming out of this tabulated, but also visually. And if we want, we can create a profile view of this. So if we define a profile path, it's telling us to click the furthest node, and you can see it's going to automatically generate that for us. So here we go. We've got that, and we can see there's two separate paths that it can use. So those are the two alternatives it can use there. And if I want, I can also specify a second node manually to just create a section or a portion of that. Now, at any point, if I now click on a node, you'll see that we've got some EPANET results, or the same for pipes. We've got maximum flow, maximum velocity, maximum head loss, and the final status, is it open or closed? So yeah, that's currently where it is. There's a bit more work to be done here, but it's looking pretty good so far, and really easy to set up. Hope you like that. Give us a like. Thanks. Bye.